Hello students. So we are back in action and today we will discuss students aromaticity. It is an important topic for our examination and many questions have been asked from this topic. Many questions have been asked. So aromaticity, uh, basically any compound that has a characteristic smell, the characteristic aroma from which we can characteristic aroma. So any compound with this characteristic aroma can be aromatic. But as far as our exam is concerned, we don't have the molecule on a practical level. So we have to decide it on pen and paper. So in order to decide whether a compound is aromatic or not, we have to look for certain criteria. Now, what are these criteria? First of all, the compound must be cyclic and it must have complete conjugation. The term we are describing is conjugation, or you can say, let's say, complete resonance. The molecule should be resonance rich. It must be cyclic. It must be in complete conjugation, or let me just be absolutely sure that I write it. Resonance. There must be resonance. There are a lot of conditions for resonance. A double bond, single bond, and double bond in an alternate fashion, or double single plus charge, double single minus charge, double single lone pair, or double single free radical. So these are the conditions for resonance, my dear friends. And now the third one, the important, the system must be planar. Planarity is an important criteria for this. If the system is planar, then we can consider any molecule to be aromatic. Not the guarantee, but it could be aromatic. For planarity, the carbon we are looking must be sp2. If our carbon is sp3, sp3 means all single bonds with the carbon. If it is sp3, then it will be non-planar. As we all know, sp3 carbons are what? Tetrahedral in nature. So non-planar, and hence it is called non-aromatic. Now, the last but not the least, we have to find the pi electrons. That's an important thing also. Pi electrons, and it must be in accordance with the Huckel's rule. Now, let us discuss the Huckel's rule. It says the pi electrons will be in the format of 4n plus 2. 4n plus 2 pi electrons. Consider n to be any integer starting from 0 to 9. We can get the answer that we can have 2 pi electrons for 0. We can have 6 pi electrons for 1. We can have 10 pi electrons for considering n2. Then and so on, we can have 14 pi electrons. So if our pi electrons are in the format of 2 pi, 6 pi, 10 pi, or 14 pi, we can say our molecule can be aromatic. So in order to be aromatic, a molecule must qualify all these four criteria. First of all, it must be cyclic. There must be complete conjugation. The system, the carbons must be planar, and there must be pi electrons in the format of 2 pi, 6 pi, 10 pi, or 14 pi. So what have we learned from this particular slide, that for aromaticity, there are four conditions to check it clearly. Cyclic system, complete conjugation, planar system, and the pi electrons in the format of 2 pi, 6 pi, 10 pi, and 14 pi. Now, many students have this problem, sir, how to calculate pi electrons? Now, we know sp2 carbon, that is easy to spot. We know resonance, look here, that is so easy to learn, so easy to find. The double and single and double, the double single, the plus, the double single, the minus, the double single, the lone pair, the double single, the free radical. Now, the cyclic system, that is clearly evident from the question whether the system is cyclic or not. But what about these pi electrons? How can we find the pi electrons in any system? So let me just show you. Let's clean it up a bit. So now pi electrons sat on a ball. Now pi electrons, It's very, very simple. Now, if you have a double bond in the system, a double bond, a carbon-carbon double bond, carbon-carbon double bond, that is equivalent to 2 pi electrons. Okay. Now, the second thing, if you have negative charge in conjugation, negative charge part of resonance, then it is equivalent to 2 pi electrons also. Now, considering the third thing, that is the lone pair of electrons. If they are in resonance, then they are also equivalent to 2 pi electrons. So here we have the pi electron criteria. Pi electrons, carbon-carbon double bond, 2 pi electrons. Negative charge, 2 pi electrons. Lone pair of electrons, 2 pi electrons. So let me show you a question. The most common question is the one and only the benzene. Look here. This is our benzene molecule. Consider this and look here. So first we have this carbon and this carbon, the double bonds. So this here we have 2 pi electrons. Now look here, this carbon and this carbon, again the double bond, we have 2 more pi electrons. And lastly we have this carbon and this carbon, the third double bond, and that is our 2 pi electrons. Now just go for the summation, 2 pi, 2 pi, 2 pi, 2 plus 2 plus 2, that is equivalent to 6 pi. So in this system we have 6 pi electrons. That is in accordance with our Huckel's rule, because in Huckel's rule, what we have learned in the previous slide, let me be absolutely sure that you just do not miss it. Huckel's rule. So 2 pi, 6 pi, 10 pi, 14 pi, and so on in the order of 4n plus 2. So now for this particular question, what we have established is our benzene molecule contains 6 pi electrons. So it fits in the criteria. Let's see what other criteria we can also study. Now, if we look at the benzene, it's general knowledge that it is a cyclic molecule. It is a cyclic molecule. So that is 2 out of 4. Now let's look for the resonance. Look here, my students, and follow the marker. A double bond. Here we have the double bond. Then comes a single bond. The single bond, and then comes the double bond. Interestingly, we have resonance in this part of the ring. Now, let's move forward. A double bond, then comes a single bond, and next to it is also a double bond. So, double, single, double. It's again resonance, and double, single, and double resonance. That is the complete resonance we are talking about. Complete resonance. All the carbons are part of the resonance. No carbon is not in conjugation. All of them are in conjugation. So the term complete conjugation, it fits, my friend. Complete conjugation. So criteria 1, 6 pi electron. Criteria 2, the cyclic system, that is also been seen. Criteria 3, complete conjugation. Now let us look and look for the fourth criteria. That's an important one. Plenarity. Plenarity. It's an important one. Now, let me just give you a basic idea. If a carbon is bonded with a double bond, any carbon with double bond, that carbon will be sp2 hybridized, or double bonds, my friends. If a carbon contains a triple bond, let's say it's a cyanide CN molecule. If it is a triple bond, 1, 2, and 3, it is sp hybridized. And if all the bonds are single, it will be sp3 hybridized. So what we are looking for is this sp2 carbon. Now look here, this is benzene molecule. Let me just change the color. Let's go blue. This carbon, this one, is the healthy one, the blue one. Look here. It has been bonded to the other carbon with a double bond. So it is sp2 in nature. A double bond carbon is always sp2 in nature. If, one more thing, if it is a system having two double bonds, a carbon with two double bonds, that is sp, my friends. That is what? Sp. But a carbon with a single double bond, that is sp2. On this carbon, same thing goes for this carbon. Blue one, it is sp2, my friends. Now this carbon, look here, a double bond. So the double bond, a single double bond. one and only double bond, sp2. Now the next one, look here, a double bond and a single bond, but what we were looking for, a double bond, again sp2. This carbon, interestingly, one double bond, and I just highlight this, and this is again sp2. Now this carbon, a double bond, sp2. So what we have learned is any carbon with a single one double bond, one is necessary. If there are two double bond, then it is an sp carbon. So sp2 carbon, the ideal condition. So planar. So students, we have established 6 pi electrons cyclic system, complete conjugation and planarity in our benzene molecule. So we can consider this to be aromatic in nature. So benzene is aromatic in nature. Now students, let us deal a question from the JEE Advanced 2017 exam. So with this, we will conclude our video for today's topic. So just give me a second. So students, we have this amazing question from the JEE Advanced 17. So in this question, few species are given, few molecules are given. It is about 4, 4, 8 and 1. There are about 9 molecules and we have to judge which of the following are aromatic. So one more thing, what we need to know is about the anti-aromatic species. The anti-aromatic species. So if you are looking for something anti-aromatic, look here. It contains all the cyclic, all the essential conditions. It is cyclic, conjugation, complete conjugation. It is planar, but it follows 4n plus 2 format. Just okay. So there was a slight disturbance. It has 4n pi electrons. It has 4n pi electrons. So it might have 4 pi electrons or 8 pi electrons or 10 pi electrons, sorry, 12 pi electrons or 16 pi electrons. So n could be any integer from 0 to 9. Now look here, look at this question. It is not the very best question presented by the JEE, but it is what it is. So look here. Now for the very first thing, look this one. This is a simpler question. Double bond, pi electrons, and a negative charge, pi electrons again. 2 plus 2, that is 4 pi electrons. And if it has 4 pi electrons, the system is anti-aromatic. Now look here. Again, 2 pi electrons. All the conditions are satisfied in this question and in this question. Look, cyclic, conjugation, planar. So no worry at all. 2 pi electrons, cyclic, conjugated, planar. 2 pi, aromatic. Find the first one. That is aromatic. Now look at this question. Now in this particular question, we have these two carbon, the hidden gem. These are CH2. CH2 means all the bonds are single bonded. Single bonded means sp3. So for sp3 carbon, you need not to see anything. It is just non-aromatic. Non-aromatic. So if there is a sp3 carbon, then non-aromatic, no discussions required on pi electrons or anything else. Okay, so if there is a single carbon that is sp3 in nature, my friends, then the system, the complete ring will be considered non-aromatic, irrespective of the pi electrons. It doesn't matter how many pi electrons it has. sp3, non-aromatic. End of discussion. Now let's move forward. Look at this molecule. So 2 pi, and 2 pi. Here you can see the complete conjugation. Double, single, double. Look here. Double, single, double, and then double, single, plus. And same goes in this part of the ring. So cyclic, check. Planar, check. Resonance, check. And pi electrons, 6 pi electrons, all check. Aromatic. As simple as that. Now look this one. This one has 2 pi here and 2 pi here. 2 plus 2 equals 4 pi. Anti-aromatic. 4 pi means anti-aromatic. Now look here. 2 pi here, 2 pi here, and 2 pi here. The negative charge, 2 pi electrons. Conjugation done. Cyclic done. Planar done. Pi electrons, 6 pi done. So aromatic. Now comes this one. This one is a tricky one. Now we will study both rings. If you study this ring, there is a CH2, there is a CH2, and that is sp3. So this part of the ring, this one, this part, that is non-aromatic, my friends. But if you consider this part, look here, 2 pi, 2 pi, and 2 pi. All are in conjugation. The system is cyclic. The system is planar. So this part is aromatic. So if in two rings, one of the part is aromatic and the other part is non-aromatic, the molecule is considered to be aromatic. That's an important thing. If both parts are aromatic, then 100% aromatic. But if one of the part is non and other is aromatic, the molecule is considered aromatic, my friends. Look here, it will be aromatic. Okay. Now what we are left with this one, if we consider this ring, look here, 2 pi, 2 pi, 2 pi, 2 pi, 2 pi, 2 pi, cyclic planar, cyclic planar, cyclic planar. So all the conditions are satisfied. This part is aromatic. Now consider this part. Again, aromatic. So overall, this molecule can be considered aromatic. Now for this question, this is from the NCERT exercise. NCERT exercise. Now if you continue in the usual approach, that is 2 pi, 2 pi, 2 pi, and 2 pi. It's a tricky one. It's 8 pi electrons. 8 pi, we consider this anti-aromatic. But my friends, the answer is a slight change of plan. This one is not anti-aromatic. It is non-aromatic. How come this be non-aromatic? So if we consider this cyclooctatetraene molecule, it is non-aromatic because in 3D it has a tub-shaped structure. This molecule is tub-shaped in 3D. So that is why it is non-aromatic, because it is non-planar, my friends. It is what? Non-planar. Now, let us count the aromatic species here. First one, this one was the aromatic. We have 1. Then we have, this one was the aromatic. We have 2. This one is also aromatic. We have 3. For this system, we also have aromaticity. We have 4. For this system, we have also find the aromaticity here. That is 5. Okay, let us recount. First one, non-aromatic. Second, anti-aromatic. Third one is aromatic. This one is non-aromatic. So this is our first aromatic product. Now look here. The second aromatic is this one. And that is anti-aromatic. So just forget this one. This one is also aromatic. So 1 aromatic, 2 aromatic, 3 aromatic, 4 aromatic, and 5 aromatic. So the answer to this query is there are a total of 5 aromatic molecules. So I hope you love it, students. This was all about aromaticity and a simple question from the JEE Advanced. So in the next slide, in the next lecture, we will try to learn something else. So till then, keep learning, keep watching, keep loving, and we will continue this very soon, and we will be entertaining you with some other amazing concepts next.